Hello, everyone. Hope that you've been having a good week, as I always say. You notice today I went for the eggshell white look because of the particular lighting of my room and just the webcam's quality. I'm just going to run with it. Maybe I'll crack a few jokes. Okay, sorry. So let's talk about a few things before we jump into the final lecture. So, first of all, because the extra credit submission deadline has passed, and a few people did attempt it, so I was very appreciative of that. Um, I'll explain why DB. Remember, we talked about blind sight. So with blind sight, remember we had said that the patient DB could not experience any conscious vision in the left side of his visual field, although they were able to recognize the position of a light or of shapes, X's and O's in their visual field, even though they couldn't experience any type of conscious awareness. And so the reason why, the question I asked was, why, when they did the light, did they test at different angles? And the answer is because what we talked about with one of our diagrams, we can map on the visual field onto the visual cortex. And so by changing the angle, they're testing different parts of DB's visual cortex for its ability to perform that task. So they moved the angle around so that different parts of the visual field would test different parts of the visual cortex and his acuity and his ability to be able to detect correctly whatever he's being presented with. So that was the answer. I have those. So if you got that right, then I will be giving you an extra credit point on your final exam. So with that said, this is our final lecture. Again, make sure that you've completed assignment 4, especially for this last one, because there are some demonstrations that are going to be very helpful and, again, very interesting, I think, that I want you to have down in preparation for the content of today's lecture. So let's think about what we've covered so far for attention, because it was a big chapter. We talked about attention in general, what just attention is, and the idea of multitasking, right? Driving and multitasking. We talked about how we seem to filter information out, right? The different models of attention, so how some information kind of falls to the wayside, and how we focus on and select certain information, how we have a limited capacity. We went into that theory. And then last lecture, we talked about automaticity and the idea that there are certain brain processes that we do automatically. And especially when it comes to attention to things, we have evolved to have certain reactions, reflexes that are automatic, as well as some learned behaviors like riding a bike. Those things are automatically, we've developed to have automaticity. The last topic that I want to talk about is how our visual attention works. Because even though we've talked about vision in the past with perception, and we kind of are in some way taking a step back, I want to talk about how our vision works as far as perceiving and combining things. Because we kind of just said, oh, your brain sees things and then it just makes sense of it. And again, that seems like a fine explanation to us, but scientists are picky. They like to pick apart things and understand them and specify mental processes that go into a certain phenomenon or experience or brain process. And so that's what I'm going to talk about today with visual attention. So I'm going to prepare my little laser pointer. And so I'm going to start. The general goals for today are to kind of understand how visual processing works, how we move our visual attention around. And then also some of the things that are required, the things that we might not expect are required for visual attention. Because visual attention, when I move my focus from the webcam here to my dog laying on the table over here to my keyboard right here, it happens pretty flawlessly. And so again, it's something that we don't think about because it just happens so fluidly. But there are some components that I want to go over that I think are interesting. So what goes into this visual attention process? So we're going to go over each one of these different processes in turn. The first one is orienting. The second one is alerting, and the third is executive attention. I don't really want to give a small summary because we're going to jump into each one of them. So let's jump right into orienting. What does it mean when we are visually orienting ourselves towards a stimulus? So orienting is, as it sounds, we are changing our focus towards a particular object. But this can happen with or without us moving our eyes. So we can use like our peripheral vision. So right now, even though I'm looking at the webcam, right now I'm looking at my dog that's right here with her head down. Sorry, I didn't mean to poke in the ear. Good. And she's right here, or I can focus on what's going on outside of my window right now, which is nothing. Nothing's going on. But the reason I know that is because I have shifted my attention. Even though my eyes are here, I've oriented my visual attention over to that. Now, I could go like this and look, and I've also oriented, but we can shift our visual attention to our peripheral without moving our eyes. And often this orienting process is driven by the goals that we have, right? So I want to kind of know what's going on. Has anyone done that where they hear something going on outside and they don't really want to look, or they want to look like they're not actually looking at what's going on, so they're kind of just, you're kind of, what's going on over there? And everybody's looking through the peripheral, right? That's orienting. So our goal in that instance is just to understand what's going on. And so the idea of refocusing our attention with or without eye movement is called orienting. And the reason why we know that we orient, the evidence for visual orienting, is through a condition known as hemispatial neglect. And so patients who have brain damage, well, these particular individuals, they have an inability to, or they fail to orient visually towards a portion of information in the visual fields. So it's different than blind sight. Blind sight, the person is not aware that they are experiencing any kind of conscious visual information. I cannot see this side in front of me. Someone with hemispatial neglect actually will think that they are experiencing the entire visual field that they're looking at. The trick is their attention is focused on information on this side, and so they assemble it together, but they neglect this other half. And so what does that look like? So how do we find evidence for this phenomenon, this hemispatial neglect? So one way we demonstrate this is we have patients who have this condition draw objects. And so we have a clock, we have a house, and we have a cat. And so why does the cat have two tails? It's 9 tails, okay? It's Pokemon. What we see is that an individual with hemispatial neglect will think that they are viewing the entirety of the object. But in actuality, when we have them draw it, they only draw one half of the object. So a few questions I've often gotten in the past from students about this. Oh, why did they draw a circle? Well, I mean, again, it's their visual information that is inhibited, not their understanding of circles, right? Not their memory. So they might just drawn a circle, which it seems like what they did. They just drew a circle because they know that they're looking at a clock. Why is more of the cat's face drawn, which I mean is a particularly good drawing of a cat, at least for my standards. Well, maybe again they could have shifted their eyes a little bit, because again it splits the visual field. But if their eyes shifted over, maybe they caught a little bit more of the cat's image by having their eyes shift over a little bit from where they otherwise would have been looking at their fixation point, right? And so, but we still see here that there's some neglect to some degree. And again, I could also assume that maybe hemispatial neglect, it's going to not be perfect, right? It might not be specifically down the middle, but it's going to depend on how much damage there is in the brain, how much information is still being processed in that part of the visual field, right? So any of those explanations can account for the phenomenon that we're seeing here. But you can still see, by and large, they are neglecting a good portion of the image. All right, so we have a couple other examples here. These patients were asked to draw a daisy and a clock. And again, you see them drawing some things. And even here, they drew 1 through 12. So again, they have an understanding of a clock having all 12 numbers. And so it probably becomes this conflict between memory systems that are intact with visually what they're experiencing. And so you get this probably, I'm assuming, this combination of competing information, that I know what goes into a clock, I know what goes into a daisy, but that's not what I'm experiencing visually. And so this shows that we orient because these individuals, because of the damage that they have in their brain, are unable to do so. And so they again, it would report that they're experiencing their entire visual field completely. So that's what makes it different from blind sight, is they do think that they are experiencing everything. But when they're asked to produce it, it turns out that their brain is not processing a particular portion of what they're seeing. The next process, next after orienting, is alerting. And alerting comes more as a bottom-up type process. And so alerting would be increased sensitivity in anticipation of a stimulus that we think is going to come towards us. So what this increased level of arousal or anticipation, arousal in a physiological sense, is called vigilance, right? That we are becoming a little more vigilant, a little more ready, prepared to respond when we feel like a stimulus is about to appear or is approaching. So for example, let's say that you're in class and the teacher walks up, and that's a demonstration that's probably very weird and also probably doesn't work outside of a classroom. You imagine, so let me just describe it. Let's say you're sitting there, and I'm sure we've all had this experience in a classroom, and you're sitting there and the teacher walks up to you and looks expectant, like they want a response from you. And you're like, even if you've been listening, right, you have this vigilance, this increased preparedness for a stimulus that's going to be coming your way, right? Someone approaches you. If I were to call on you, if we were actually holding class, or whether in person or virtually, right, you have this sudden, oh, I'm alerted, right? I'm ready to go. I feel like I have to be ready to respond. That is visual alerting, right? When this visual information comes towards us and we go, I need to be ready to respond. I need to be ready. Which again, the extent to which we become vigilant is going to be probably an individual difference. I know for me, I'm a little more anxious of a person, so if someone walks up to me, I'm like, okay, here we go, here we go, here we go. It's a little more nerve-wracking for someone else, and I'd be like, all right, I'm prepared, but they're otherwise not as bothered by it. So it's going to vary from person to person, of course, right? But the idea of alerting is that we're preparing ourselves to deal with or respond to an incoming visual stimulus, right? The trick is, if nothing really changes or nothing comes up, we don't get alerted, and we're just kind of seeing the same stimulus or environment, that can lead to what's known as fatigue. Well, I mean, that can lead to fatigue. And so what happens is then that's when we start to experience things where we start to fail to notice certain things. So long drives, it becomes a problem where our visual attention can maybe be slower to react to an incoming stimulus, because if we're just driving and nothing is really changing, then we just get used to it, our visual attention fatigues, and then something new comes and we're not as prepared to respond to it because we've kind of gotten a little tired visually. It's also a big concern with lifeguards. When you are just standing there or sitting there and you're watching, most of the time nothing happen, especially at a beach, right? When there's the Chicago beaches are pretty large, so you're sitting there, people are around, but it's mostly nothing's major's going on. You might have a bit of a slower reaction or a realization when something actually requires you to become alerted because you've fatigued. And so, I'm sure that's influenced some type of policies about how often you should cycle out lifeguards to make sure that, although fatigue will still happen, maybe we're going to keep the lifeguards a little more vigilant. And I'm not saying it's like a 5-minute, oh, sorry, I need to reset my batteries. But, obviously when we're talking about life or death situations with a lifeguard and someone like drowning or getting pulled away in a riptide, you want the person to be prepared as possible, to react as fast as possible, to make sure they can save the person with the highest likelihood possible. And so fatigue becomes a big issue. So just to kind of review, orienting, as we said, this moving of our attention, that's more of a top-down process. That's, we have a goal or we're interested in something, and so we move our attention either with our eyes or without our eyes to focus on and process that information. Alerting, in contrast, is more of a bottom-up process. We have this information coming towards us, and we're preparing ourselves to respond. So the last one that I want to go over is executive attention. And so executive attention is something that we're gonna talk about in a couple different ways, but think of it as this control center. So you remember when we had that diagram, we had the desk with the chair, that's the command center for you of where your attention gets directed. That's the executive attention. And the idea of executive attention is it helps to both allocate resources to different things. So when I go, okay, so I know that my friend wants to talk right now, but I really need to study. Allocating resources done by the executive attention. But when there's a conflict arising, where there's a couple things maybe grabbing our attention, or there's things that we have to deal with that are competing, the executive attention system helps us to resolve those conflicts. So when we need to make decisions on where to or how to allocate our resources attentionally, that's the executive attention. If there's an error, right, having to determine and focus on and process for errors, that's the executive attention. Helping to allocate attentional resources when there's a dangerous situation, right? So if I'm swimming, for example, and a shark swims by, okay, my executive attention is going to be like, hi, we need to focus on that, right? And this is part of that Kahneman capacity theory, right? That diagram we talked about, this enduring disposition of wanting to survive. So dangerous situations, our executive attention helps to push our focus towards those dangerous situations to help us. Also, help us to breaking habits or suppress incorrect information or automatic behaviors. That's the Stroop effect, right? The Stroop effect that we talked about, where we have the color of the word being different than the actual color being of the written word. That overriding that automatic process is the executive attention. I would even say when we develop automaticity habits and we have to replace those behaviors, then that's our executive attention. And so one example I have of that is when I'm teaching Taekwondo, one of the big things is that obviously when you first start out, you have kind of these coarse movements. Let's say you're making a block. So you might just kind of go one hand like this. This is a knife hand block. And so you're blocking something like this. But when we're doing the forms of our techniques, it's more effective for us to use both hands because we get more of a snap, a little more strength. And so everyone, adults and kids, are used to doing this because they built a habit. And it's not just a part of their technique, it's a part of their automaticity, right? It's automatic habit. And so in order for me to get them to be active-minded, as I call it, to replace that and use both hands like this, right? To have a stronger technique or to have a better stance or to replace a certain move with a new correct move. That's what we call, or we would use executive attention to override that habit, because it is a more active process. It actually takes a lot more effort because it's difficult. Our brain, again, wants to handle this automatically. And so to have my students replace that with the correct action, they need to take their time. They need to be more active and really use that executive attention to override that automatic behavior, to replace it or update it with that new action instead. So our executive attention plays a major role in us updating and replacing bad habits with new ones, whether we're just getting rid of those habits or we are trying to replace habits with new habits. So pretty cool that we do this. Again, it takes effort. This one takes effort, but it's really cool that we have a system that allows us to do all this. And it does all these things. It does all these things. I need to stop pointing with my hand. It does all of these things, which is particularly cool, that we have something that can help us with these more complicated tasks. So we're not just, oh, here's my habit. That's what it is now that it's ingrained. But we can update it with effort, but we can work hard with our executive attention to make those updates. So we have this visual attention process, right? We have this orienting, moving around. We have alerting, and we have executive attention, which is helping us control. But how is it that we start to integrate the perceptual features? When we said perceptual features, remember, that refers to shapes, colors, sounds, loudness, tone, anything like that. Those features, those perceptual features, how do we integrate that information together in order to recognize what's going on? So, if you remember from assignment 4, I had asked you to do a couple different search tasks. So the first one, I had you search through a series of images where you had to find just a particular character, but the only thing that was changed was one feature, right? So this red X here, we have the red circle, we have the green T. right? And so I had you find these different features, and this should be very, very easy. You should be like, why am I doing this? This seems like it's so simple. But then I had you do another series where I asked you to see how long it would take you to find the vertical rectangle, which boop, is right here, right? That might have taken you a little more time. Or the red circle, right here. Or the green square, which is right here. But again, it's not impossible to find. It's just taking a little bit longer. Why did it take longer for us to find this compared to these other ones here? Why does this seem to be very obvious, but then these, all of a sudden we do these other ones? If our brain is so good at processing different perceptual features, why does this take longer? Well, what we call these simple searches where there's just one character, so we call this what's called a disjunctive search or a pop-out search. And the idea is that the actual recognition of these features and the distinction between these different features is pre-attentive. So we don't actually have to focus our mind's eye on this information and process it in detail in order to recognize that there's a difference there. So before you even recognize that you were looking at a red X necessarily, you already saw that it was there in general. It just popped out at you. So you didn't have to go and start to attend to everything. It was just there, right? And so this is, that's what we mean by pre-attentive, is that it's just, as soon as you see it sensory, with our sensory system, we already recognize that there's some kind of difference there. And we can do this regardless of the number of entities. I could have had 10,000 X's, assuming you can fit it all within your visual field. If I have this one red X, you're still going to notice it pre-attentively because it's there and your senses pick it up that there's a distinction immediately. And so this search happens in parallel because you're looking for this, and because it's pre-attentive, you just kind of get it, and the search, you're looking through everything and you see it, so it's happening at the same time. The search of all the items is happening all at the same time in parallel. In contrast, this is what's known as a conjunctive search. The idea being that we are no longer just looking for one dimension of feature in order to distinguish the unique object. We are having to assemble multiple features together, right? Because we now have, instead of just a bunch of X's and then there's two colors, we have circles and squares, and we have pink and green squares. And so because there are multiple dimensions, now we have to put our attention towards assembling these different features together to make the object. And so instead of the other one where it kind of pops out and you're able to look at all of the items in parallel, we now have to be more serial with our search, which means one after the other. We examine each item, we put our attention towards it, and we assemble the different features together until we come up with the correct one, which would be right... Oh, do we even have it here? I can't even see it now. Until we find the appropriate item that we need to. So that tells us something, right? That tells us that when we have to start to assemble different features together, even though our brain does it for us, it still requires attention. It still requires a little bit of effort on our brain's part in order to assemble those features together, right? If there's just one, that becomes very easy, but if there's multiple, it's going to continue to compound, right? We're going to integrate a couple of features. Our brain needs to integrate those different features together. So that's what feature integration theory talks about, is that when we process visual information together, we are assembling different maps of those features together. So we have different maps, which in many ways maps onto the different neurons that we have that process the different types of information. But a way that we talk about it in theory is that those neurons take in certain types of information like curves and colors, and then mentally we take essentially maps of what we're seeing of the certain curves and colors and edges and shapes and textures, and we start to overlay these maps to assemble the object into a meaningful visual whole. As we add and integrate more maps, more mental perceptual maps, we have to use our attention more, and it takes more time because we're trying to assemble everything accurately, and so that takes more time to layer on these different features to understand. Now again, when we think about time, we're thinking like maybe seconds or minutes. It doesn't take that long, but it takes more time with more features than when there are less features, right? So again, we have to kind of change our frame of mind. It's like when you talk about anthropological time happening over millennia, and it's hard to conceptualize. When we're talking about our brain processing time, we're not talking like seconds or minutes or hours like we usually experience. We're talking fractions of seconds or milliseconds, well, which would be fractions of seconds, or seconds. But again, with the brain power that we have, the brain processing ability we have, that's the meaningful scale that we're working on. And it does take longer when we have more maps that we need to assemble. So because attention, right, registering an object, processing the features takes time, it leads to two very interesting effects. The first one, on the next slide, I want you to just register when you find the Q in the image. Ready? Go. Should have been pretty easy, right? We have this pop out of this Q. Now I want you to find the O. Okay, hopefully you got it. You found it right here. Now, did one of these two searches take longer? So looking at those arrays, what we likely found was that searching for the Q amongst the O's was easier to do than searching for the O amongst the Q's. And the reason is, when there's more information for us, then it takes more time for us to process those features. So that extra information can help facilitate that search because it pops out, right? It makes it more apparent. Like we said, finding something that's unique, that's different, that one fact feature that's different can actually make it easier to process because it's one feature difference. But when everything has that extra information and then we take that information away, our brain has to do a little more effort to try to search for it because it's used to looking for this new extra information, and then it's harder for us to have it not be there. So I think things kind of blur because it starts to fill in, okay, everything has this extra information. And so we have to go a little more carefully to find out what doesn't have that information because our brain is used to seeing all that extra information. So that extra information, like the Q, when there's O's that don't have that extra information, this is just that little extra tail, our brain is drawn to that extra information. But when we reverse it, we have to search, and our brain is expecting that little tail, and we have to work to try to find the one that doesn't have that. That takes a little extra time. The second interesting experience that we have with with the feature integration theory is I want to show you a diagram, and I want you to answer a question afterwards. Ready? So make sure that you're focusing on the screen, and here we go. Was there a white square? Now I know I presented that very quickly. Was there a white square in the diagram? You might say yes, but in actuality, there wasn't. There were these light blue squares and white circles. But you might have said yes because of what's known as an illusory conjunction. So when our attentional system does not have the appropriate amount of time to process the information that's being presented, it creates errors because, again, our brain is working to integrate things and make sense of things. And if it tries to do that as best as it can. But if we get overloaded, if we don't give it the time to process appropriately, there's going to be errors because our brain just takes what it has and then integrates it. And so it registers, in the case of this illusory conjunction, it registers that there are shapes and there are colors. But because I overloaded your attentional system by not giving you enough time to properly process and integrate those features together, it led to this illusory conjunction potentially where you saw a color and shape, or you had a memory that there was a color and shape that didn't actually exist because your brain didn't have enough time to correctly process everything. So it resulted in incorrectly bound features. So this tells us that integrating features requires attention, right? We need to put our attention towards objects in order to visually assemble the information together. It doesn't take very long. Again, this is a short, fractions of a second process that we just usually take for granted. But we do find that it takes more time and it requires our attention in order to do so accurately. Otherwise, we can have these experiences where things get assembled that shouldn't be assembled, or we miss out on information. So, there are some other limits. So, each of these you also should have experienced as part of the assignment for assignment number 4. And so I'm going to discuss what's actually going on with these phenomena now. So with attentional blink, what's happening? So let's go over what I asked you to do. So over time, when we're focusing on something, and we know this now, let's keep in mind that visually attending to an object requires time and a little bit of effort on our brain's part. So I gave you 2 different tasks. I showed you this array of letters, one after the other, and I told you to report when you saw an X. And then I also asked you to ignore an orange letter. And so I showed you like X, Z, or no, I can't say X, BAMLNOP, and one of the letters was also orange. You ignore the orange letter and you reported when you saw the X. That should have been a particularly easy task. I had you then go through a similar procedure, but instead of ignoring the orange letter, I want you to report the orange letter. So just by saying, yes, I saw the orange letter, and then also report when you saw the X. So here's a diagram. So BXFSNORE, right? So you report the X, and on the first pass, you ignore the orange letter. On the second one, BSFN, you report this, right? Because now on the second task, I asked you to report the orange letter, and then you should have also reported the X. Now, what probably happened on that second one, when you had to report the O, the orange O, you probably missed reporting the X. The reason is, as we talked about, attention takes mental effort and it takes time. We need time to register and report what's going on visually. So if I were to vary the position of the X and the letter, and also varied what I expect you to do with each of those 2 different letters, it's going to result in different effects. So if I present the X early or late, and they are separated from the orange letters, and I'm asking you to report both, it shouldn't be a problem. I report the X, I have enough time to attend to this, and then move on, and then I get the orange letter. Same thing here, very far apart. Now, if I'm just having you ignore the orange letter, it doesn't matter, right? Because you're just dismiss it. You don't even care. Your only focus is the X. That's easy. But when I ask you to report both, if they're not properly spaced apart, right here, your need to attend to and register and respond for this leads to what's known as an attentional blink, where your brain is no longer taking in additional visual information. And so you miss reporting the X because your brain is preoccupied with processing that you saw the orange letter, right? So when people attended the orange letter and it's close in proximity, you miss the X. So information coming in is not attended to, as I just said, it's not attended to when we're processing a stimulus. So I asked you to process the orange letter, you missed the X. The reason is because your brain was preoccupied. And that's called an attentional blink. So here's a nice diagram showing this. So when I told you to ignore the orange letter, okay, so this, when you get counted this, who cares? It doesn't matter. I'm not even paying attention to it. Okay, I see the X, and then this right here would be my attention of where I'm recognizing I saw the X and reporting I saw the X. So if I were to ask you to report these letters, you would miss them because your attentional resource is preoccupied with processing and reporting that you saw this. But when I overlap the two, you need to report seeing the colored letter, the orange letter. And then you move on. And then the X is within that attentional blink span. That is going to lead you to fail to report the X because your brain is preoccupied processing this N, and then that moves on. And then by the time it's finished processing and reporting the N, the X has already passed. So the implication of this attentional blink is that processing information, it takes time and it takes resources. That's already what we saw with that feature integration theory, right? So this is just a reinforcement of that. Another time where when we are taking in for information, we need to allow ourselves the time to visually process what's going on. Now, usually that's very easy. And when things are more familiar, when like visual things are more familiar to us, I'm sure that takes less time. But at any given moment, we are either taking in new information or processing the old information. And the attentional blink shows, okay, so because I'm processing this old information, I'm going to miss this new information, right? Unless I tell you to not worry about it, and then in which case you're just processing that new information when it comes up. And there's actually a pretty big implication for this with the classroom. When we go for so long in a classroom, so there can be a lot of, and this goes back to that capacity theory, we have a certain amount of attention. And so if our attention is preoccupied processing what we just heard or what we just saw, then if I were to continue on very quickly, you might miss my next point because you were processing the old information. Or if you go, oh no, they're still going on, they're still moving faster, I need to continue to focus on the new stuff. That can come at a loss of the old stuff, right? There's this balance. Our attentional capacity is limited. I'm getting new information and I'm processing old information. And at some point, our brain can't handle all that and a decision needs to be made. That's one of the fortunate, I was going to say fortuitous, whichever one you want to use. It's one of the fortunate things of this video lecture is if I'm saying something and you're processing it and you realize you don't understand, or I've moved on a little more quickly than you're ready for, you can rewind. I hope that you're rewinding because then you can give proper attentional resource towards the point that you were trying to understand, and then also give appropriate attentional time and effort towards the next idea, right? So this balance is something that we can keep in mind for all of our classes, for all of the things that we're dealing with, right? That at any given time, we have to take new information and process old information, and we need to be respectful of those if we want to fully understand what we're hearing. So that's one thing. So that's attentional blink. There's also something called repetition blindness, which is another part of assignment 4. So if you recall, I asked you to view a list, and then after viewing it for a very short time, again, I kept it very short, I asked you to write down all the words that you can remember seeing. And so this is the list: sausage, biscuit, eggs, cereal, eggs, and toast. And so if you have your assignment handy, I want you to see if you recalled eggs twice. Or maybe you just remember. Did you recall eggs twice? You probably didn't, right? And if you didn't, that's totally okay, right? Because again, I presented this information very quickly to you, but this is something different. So attentional blink is that over time, when I register something, I'm going to not process it. I'm going to miss out on other information. This is more of our brain being economical with its resource. So our brain is, you look at sausage, biscuit, eggs, cereal, it sees eggs again, and it goes, I've already got that information. I don't need to worry about it. Cool. And it dismisses it. And so as far as a correct recall of this list, it's wrong, right? You missed recalling eggs twice. But as far as our brain's efficiency, our brain, okay, I know I keep anthropomorphizing my brain. And so our struggle, I'm going to try to keep saying my brain does this or decides this or wants to do this. Our brain processes eggs again and recognizes, or in some way the brain system recognizes that eggs has been presented before and chooses not to process and store that information again. So it condenses and it makes it more efficient at the loss of information, but information that the brain has recognized as redundant with earlier information. So it's another way that, again, this seems like a detriment, but it's just showing how our brain works, that visually our brain our brain processes information and makes it, and tries to apply information to make it easy. It takes in the context of what we've seen already. In this case, it'll dismiss information that's otherwise repetitive. So that leads to effects like this. New York in the spring. Or is it? Thanks, Michael from Vsauce. That was a reference for you. New York in the spring. Right? So maybe you misread it the first time. I also didn't help because I read it the way that you were supposed to be misled to read it. It's the same exact thing. It's repetition blindness. We read these, and I showed you this as your assignment, right? You might have for the first time read this and only read the once because, again, our brain processes this second the, sees that it's already been processed, and then replaces, and then just dismisses it, essentially, sets it aside. It's not important. So then we have to go back and actually process very carefully to see that there's duplicate thes, right? To see that there's that information there. So this is repetition blindness again. It's the brain trying to be economical with the resources to make sure that we are not processing and wasting our time processing multiple pieces of information that seem to be otherwise identical or the same. So to kind of just go over what repetition blindness is, this will be the last point I'm going to make. So repetition blindness, recently processed information or stimuli are not processed again if they are shown to be repeated to us again within about a half a second, right? So there's a brief window of time that our brain will see redundant information and then not worry about that repetition, right? Our brain tries to make things distinct, to take in information that is meaningful and unique. It's going to try to not focus on information that seems to be redundant because it wants to build a good representation, or it builds a representation, mental representation of clear, distinct information. So, a couple conclusions from today's discussion. First, visual attention is driven by both bottom-up information, which we called alerting, and top-down processing, which is orienting. Our systems, our visual system has what's known as an executive attention, which we're going to also call, we're going to encounter again when we start talking about memory systems after exam 1. We have a similar executive control system that helps us to direct our attentional resources and help us resolve processing issues, which comes to things like the Stroop task, where we have to make a decision and override automaticity. Our executive attention helps with that. We also integrate perceptual features and perceptual information, and that takes both attentional resource, right? It takes us focusing, taking in that information, and time to appropriately integrate that information again. We saw that with feature integration theory. We saw that with attentional blink, repetition blindness. Our brain is trying to maximize the efficiency and accuracy. And so we need time, and we need to build things that are clear and distinct, as what our brain seems to be trying to do. And so that can be, I don't want to say that's a good or bad thing, right? There can be situations where there works for us or works against us, but it's just the way that our brain works. And that's pretty fascinating that our brain does. Again, this is something that move your visual attention around right now. It's just doing it automatically. There could be something that just pops up and I visually orient towards it, or I alert towards it, and my brain does it flawlessly. That's such a cool idea. It's very interesting to see how we can break down these more complex mental processes that just seem very fluid and easy for us. That's what makes this interesting to me. That's what makes science like this interesting to me, is because we're taking these otherwise very fluid systems and going, well, what are all the elements? And there's actually a lot to dig into. So I appreciate this science. I appreciate your fascination with this science. And let's continue to jam hard on all of these other topics that we're going to go into. We're going to talk about memory systems next, which I know for assignment 2, because I was providing some comments on people's connections with the last assignment 3, assignment 2. And very interesting. I think memory is going to be a fascinating topic for a lot of people. So be prepared to be fascinated. Good luck with exam 1, and I will see you all when we go to that next lecture. See you, everybody.